Innovators Insider podcast. I am really excited for today's show. I usually say that, but I'm actually really excited this time. We have a couple of fantastic guests that Richard and I have been have known for quite some time.
Yep.
I think you'll get that through some of the stories here. And Richard, how are you doing?
I'm doing great. Having a great day. It's a beautiful day in Las Vegas today. And I am, like you, looking really forward to this episode. We're going to be talking a little bit about agile product development and some of the steps that companies are taking to streamline their development processes and their manufacturing processes. And we're going to have a focus on 3D printing and or additive manufacturing today, too. And it's my pleasure to be able to bring in our first guest. And our first guest today is Terry Wohlers. And as the head of advisory services and market intelligence at Wohlers Associate, Terry's been the preeminent voice when it comes to 3D printing and additive manufacturing for almost 40 years now. Now, we don't have a lot of Terry's time today, so I'm going to go ahead and skip his entire bio. But I do invite you to take a look at it, and we'll put that link up on the screen here. I had the pleasure of meeting Terry originally back in the early 90s at a CAD conference up there in Dallas, Texas. And it was funny, we shook hands and we sat down at a table. And the first thing he asked me was, "So, what are you guys working on down there at DTM?" He's always looking for that inside information on new processes, new techniques, new materials. And I think most often he probably finds it. So we're happy to have him here. So please welcome to the show, Terry Wohlers.
Thanks, Richard.
Hey, Terry. Yep, great to see you. Thanks for coming on the show. We've known each other for a long time. I mentioned before the show that we look a lot different than we did 30 years ago, but we're both still going strong. So, welcome to the Innovators Insider podcast. I started out in the business back in 1990 with DTM Corporation. Back then, we called it rapid prototyping. We had these big $500,000 machines. They were huge. And then the desktops came along, and all of a sudden everything switched. And all of a sudden we were calling almost everything 3D printing. And now it seems like it's changed again. So when did we get to the point where we really started talking about additive manufacturing?
Well, it was really in 2009 when the Society of Manufacturing Engineers, SME, went to ASTM International and said, "Hey, we need standards around this emerging industry." And so the group met. I was lucky enough to be a part of the first meeting where many people participated, and we had to name the committee. So this is a standards making committee. We had to give it a name. And so we had people from all over Europe and Asia, many from the US. And a number of ideas were bounced around. And of course, 3D printing had been used at that time for a number of years, but it really wasn't mainstream. I would say rapid prototyping, which is really an application of the technology. It's not technology itself, but it had been used a lot to describe the technology and its use, although its application has since, or even before then, expanded into tooling and even production applications at that point. So long story short, the group, after a lot of discussion and some debate, but by consensus decided that additive manufacturing was the best name for the committee. And I tell you what, something that I observed since then is that even the first year or two after that, the companies and the industry itself was taken more seriously, because, especially for production applications, because a company really doesn't want to manufacture with a prototyping technology,
Sure.
Rapid prototyping, but additive manufacturing it elevated it and gave it more credibility. And it didn't happen like a flip of a switch, but it did occur. And to this day, I think it was one of the best decisions that could have ever been made around this industry.
That's an interesting story, that there was such a paradigm shift because of somebody needed a name for something.
Yeah.
That's great. Again, back in the day, we would build some parts. You could measure them, you could hold them in your hand, that kind of thing, and that was really what we used that for. But in addition to that, what are some of the other things that companies are using additive manufacturing to help streamline some of their processes, their manufacturing, or their time to market?
Yeah, well, it's still being used frequently, arguably the most to get something early in your hands. So CAD tools are incredibly powerful, but it's difficult to touch a digital model, at least not in the same way that you can touch a physical model. And so to get something or a range of ideas into somebody's hands early while changes are inexpensive and to get it right. And then to use it for tooling and even, for production tooling. That's still the exception though. That's not the rule. More prototype tooling, low quantities, molds and dies for plastic injection molding, but that really honestly didn't take off as much as some had expected. Jigs and fixtures, gauges, guides, those kinds of things. You walk into a factory and the machinery, all the setups, most of those are custom and very low volume parts that go into those setups. And so it's a perfect fit for those kinds of applications. So companies are doing that in a big way. And then really the big opportunity and one in which companies have been moving toward for a very long time, and that's series production and custom product manufacturing as well. Not only large production runs, and typically it doesn't make sense unless it's a unique type, like Invisalign, like the invisible braces from Align Technology. Each one is different. The same way with the custom fit in your hearing aids. Each one is different. Same family of product, but each one is unique to the shape of someone's tooth, for example. If you're doing a tooth restoration or a drill guide for a replacement, full knee replacement, for example. And so there's a lot of those kinds of applications out there where it's a patient-specific type of a product. Eyewear, footwear, same thing. So we're seeing where the technology makes the most sense for production applications. Are we building stadium seats with it? No. Will we ever? Well, I don't know. Probably not in my lifetime. But those lower volume, higher value products, especially those that are custom or semi-custom, people will pay a premium for those products. And additive manufacturing helps a lot.
Yep. Yeah, I remember 3D Systems and the hearing aids. And certainly the Invisalign, and those, they've been mass manufacturing those for quite a while now. Are there any new trends that are happening? Anything that might be bubbling up under the surface as far as mass manufacturing?
Well, certainly human body parts, mostly synthetic in the form of titanium and cobalt chrome and that sort of thing. But to date, 250 products have been cleared by the FDA. So these are standard products, spinal products, acetabular hip cups, some craniofacial type products, head and face, ankles, shoulders, that sort of thing. But and then if an individual surgeon wants to do a custom type of product for by additive manufacturing, they can do that without the support or clearance from the FDA. But once you get into a routine series production type, then you need to get clearance. And so 250 products to date have been done in that way.
And so again, probably most of those are the items that need to be customized between one and the other.
But no, those are not custom. Those, most of those are, like I say, standard. Now they're different though. Like for example, the spacers between the vertebrae, like you're doing a fusion. Those spacers, they'll be a lattice structure. Very difficult to manufacture, really impossible using conventional methods of manufacturing. So that's what sets it apart from using conventional types of manufacturing. Still a relatively low percentage of the surgeries that are done with or aided by additive manufacturing are custom. Relatively, in comparison to all the surgeries that are done out there, or even those that use additive parts are a relatively small percentage of custom at this point.
Sure. I still consider myself lucky to have been in the business early on in the development, and to be able to see all of the changes that have happened over the last 35 years. And it's really amazing to have been able to see that. I'll put you on the spot here. What does the future hold for additive manufacturing?
Well, we're seeing major car companies look at doing major parts of cars with additive manufacturing, which we've been talking about that for 20 years. I remember about 15 years ago, I was talking to one of the big three in Detroit, and they said, "Oh yeah, in about 4 or 5 years, it'll become fairly mainstream." That was 15 years ago, and then another 5 years passed, and another 5 years it should, and it never really happened. Now it looks like it could, with some developments that are underway behind the scenes, and so stay tuned. But it's quite exciting to see, and metal too, because metal is expensive to process.
Sure,
it's more time consuming, and so typically when you get into the little bit higher volumes, into the thousands, it's usually polymers. But metals, well, most cars are, if you're talking about Lamborghini, Ferrari, they're in that 5,000, 7,000 range. But when you get into the more of the mainstream cars, now we're talking about hundreds of thousands, or maybe more.
One of the things that I remember from the early days, again, we're talking about $500,000, $750,000 machines that people, a lot of companies couldn't just buy. So the service bureaus sprung up all around the country. And then I remember at some point they all kind of consolidated. I think that might have been right around the advent of the 3D printers started coming in, and people were able to create those a little bit more cheaply. Now I think what I'm seeing is not exactly the same service bureau that we had in the early days, but we're getting these online on-demand manufacturing services. Like we have an Onshape partner, Xometry, for example. Do you see that continuing? Do you see that more and more companies will be utilizing those types of sites to get their products, get those products made?
I do. I see nothing but expansion of that concept. Not all of them are going to be successful, but I do believe that we'll see that. The whole idea of on-demand manufacturing is appealing to just about everybody.
Sure.
And be able to simplify supply chain and to bring those suppliers closer to you if possible. But rather than having these enormous warehouses of products or parts that make up products, and to assemble those, and so expensive, incredibly expensive to carry all of that, and to be able to think of one day having maybe not all but a lot of your inventory on a computer, in the form of digital models.
Yep. Build on demand.
And manufacture on demand. So and companies are doing that. I mean, look at Shapeways. That's a company that they from day one they have built product on demand, and all types of products. And so that's a company. Protolabs, a number of companies do that. And a lot of these service providers that you mentioned, the bureaus, they have transformed themselves into contract manufacturers and are doing production jobs, and really are taking it quite seriously. We did see a lot of consolidation, as you mentioned, Richard, but then at the same time, over the years, we've seen more startups and others develop. So it's a very vibrant. They are among the early adopters and some of the top users and thinkers in this industry, the top experts. And so, thankfully, they help support us year after year with the award report that we do, because they provide us a lot of great input. But they really are among the best and brightest users out there.
Yep. Well, I'll tell you what, it's been a wild ride for me. I've got to see a lot of really wonderful things over the last 30 years. I'm sure you've seen a whole lot more than I have over the past 30 years. And I really look forward to seeing what's happening in the future with additive manufacturing. I want to thank you for being on the show, Terry. It's been a real pleasure to have you. And I know our viewers and listeners are gonna get a lot out of this interview.
Well, thank you for the opportunity, Richard. Great to see you.
Yep. Michael, any questions for Terry before he goes?
Yeah. What was the very first 3D printer or rapid prototyping machine. My first one that I saw in person was an SLA 1000 that we were doing investment casting burnouts from, and everything was crazy. But what was your first?
Well, the very first to be invented and commercialized was stereolithography. So similar to what you saw, the SLA1. It was really the beta test system that led to the SLA 250. The SLA1 was introduced in 1987, but the full commercial product of 250 was in 1988. And so I had the opportunity to learn about it in 1987. In fact, I have a part in my shelf here that was produced on, it might have even been a version before the SLA1. It's a full-size distributor cap. I know, Richard, you're old enough to know what that is.
Yep.
Would you like to see it?
Yeah, you bet. Love to.
One, so I'll grab it.
All right, yeah. Well, wait for a second there. Yeah, what a great idea.
The first time I was ever exposed to the technology was actually on a TV show called Beyond 2000.
Oh, I remember that show.
And I saw a segment where they had a bottle, and it looked like a medicine bottle that just kind of all of a sudden came out of this vat of resin, and I was just fascinated by that. And it would be, that was probably 88, 89, 90. So it'd be several years before I got into the business myself. But like I say, I saw that and I thought, wow, that looks really cool. So.
Yeah, so this is a distributor cap. It's it was before electronic ignition. So this is a full-scale distributor cap. Now, keep in mind, this was built on one of the very first additive manufacturing machines in 1987. And so all the spark plug wires go into here. There's a thing that's called the points down there that adjusts the timing for when the plugs fire to cause the explosion in each cylinder to push the piston up to make your wheels go around. So in any case, when I received this, so let me. Do you have another minute or two?
Yeah, as long as you like, Terry. We just appreciate having your time. So yeah.
So I read. I don't know, Richard. You probably remember Joel Moore, right?
Of course. Yeah.
Well, most people know him, and he was the CAD guru and engineering graphics guru of the day. But he's still around. But back in '87, he published a little newsletter, and he had a little article, just one paragraph, introducing 3D systems. And so in '87, you couldn't just jump on your email or his phone, snail mail, or fax. A phone number was in that little paragraph. I called 3D Systems because I was intrigued. I didn't know. First time I'd ever heard of it. And they sent me three things: a brochure, a VHS videotape that showed. It wasn't even the SLA1. It was like a really basic prototype machine. It was like a little bitty kind of a dish thing for the vat, a little aluminum kind of L-shaped build platform, really basic. And then they sent me this, and my jaw hit the floor when I saw this. And they were using Ares Concept Station back in that time. And I remember a guy by the name of Dave Albert. You might have known Dave.
Of course I did.
STL file format for 3D Systems in our contract. It's Albert Consulting. And so they added that somehow to Ares Concept Station. And then they were off and running in order, because you had to get the CAD data over to the machine somehow.
Sure.
And so they were able to do that.
Wow.
And so they were able to produce this.
Yeah, what a cool story.
That's a great story. And it's funny. As soon as you held that up, I recognized that model. For the several years that I worked in that industry, every time you went to a trade show, or you would see different variations of the same model. In fact, there were even times when I would see something that I had modeled that had been produced in one of our machines. So that was always fun to see. And I got to work with some of the greats too, Carl Deckard and Joe Freeman. Yep. So look back very fondly on that part of my career.
Yeah, it's a lot of invention. That was one of the second or third development. Selective laser sintering, also known as powder bed fusion.
SLS. Yep.
Right. Invented right in Austin, Texas, there at the University of Texas at Austin, and then of course Nova Automation led to DTM Corporation, and then around 2001 or 2, 3D Systems acquired DTM Corporation.
Yep. And thus ended my career in additive manufacturing.
Well, it's kind of a good thing because we had you as our
the second half of my career was just as great as the first, so I have no complaints.
Good.
So Once again, Terry, thanks so much for coming on the show and telling the great story. I didn't expect that to come out, and I'm glad that it did.
No, this is good.
Yep. And good luck in the future. And everybody, every year, the Wohlers Report comes out. If you want to know everything there is to know about additive manufacturing, order yourself a copy.
Thank you, Richard and Mike. Appreciate it.
Thanks, Terry.
Nice to meet you, Terry. See you later. Yeah, I always, the whole evolution of the STL and stereolithography, 3D systems, those old days were really interesting. I worked at an investment casting company in Worcester, Massachusetts,
Yep.
and we were trying to, this is like 1992 or 3 perhaps. We were trying to use SLAs to, as tree material for investment casting, patterns instead of the wax pattern.
Yep.
But that technology is involved. There's so much variety, so many 3D printed parts that I have around me. It's an amazing world that we live in. It's almost like the Star Trek replicator. That's what we're doing.
Well, and too, Michael, one of the things that doesn't get mentioned very often is those things were fun to watch.
Yeah.
Remember back in the old days when pen plotters were a big deal, and you'd send your CAD file over to the pen plotter and watch it go and go and go. That was very similar with the selective laser sintering machines. You could stand in front of that machine and look through the window for hours and watch that laser trace across that powder. It was a lot of fun.
Yeah, don't stare at the laser too long.
All right, so continuing with the agile product development theme that we got here, we've got another guest coming in too, don't we, Michael?
Yeah, we do. I've known of Adrian Velazquez for quite some time. Back in the old days when I was a SolidWorks person and PDM person, and then I left and I became a CAD manager at a large, very global, kind of oil and gas, aerospace and defense company. I would see Adrian's name all over the forums, all over things, all over stuff, and I started seeing him when I left and joined Onshape, and I started seeing Adrian's name again. I was like, oh, this is cool.
Yeah.
So
I had the same reaction because, of course, I was in that community as well and knew Adrian, knew of Adrian and the contributions that he made to the CAD community. And now he's making those same contributions to the Onshape community. So it's a big thing.
Hey, welcome to the show, Adrian. It's so nice to see you, Adrian Velasquez of Dexcom. And what's your official title?
CAD Engineering Manager.
CAD Engineering Manager. That is a loaded because it means you'd probably do everything.
Yeah, pretty much. So CAD Engineering is the team, and we basically are like a elevated version of a CAD admin. So now instead of a single person, which I was when I joined Dexcom, now it's a team for 4 members right now, but looking to grow our role in the company as we kind of explore, like you guys saying, thank you for those memories and nice words. I'm always been about kind of looking what the tool can do for the business. So it's more about the business and making the most out of the investment that like a CAD and PDM system is. So with Onshape, we're looking to do the same for Dexcom.
Yeah. And tell us a little bit about Dexcom for folks that might not know. It's a fairly well-known company, because of but I won't steal your thunder. Please tell us.
Yeah, so Dexcom, we design and produce a continuous glucose monitor system. So basically for people that are affected by diabetes, they constantly in the past had to prick their finger to get a glucose reading. So our product primarily is a sensor that you put in your body for an extended period of time. So 10 days, you can wear a single sensor and you don't have to prick your finger every time. You can get a reading on your device every 5 minutes. And that's kind of what the continuous part is. And then the latest and the technology is that now you don't have to calibrate it. So you don't have to prick your fingers, which is a game changer for people that are affected by that.
Sure. It's kind of funny. I just happened to run across a television commercial just the other day. I forget what the product was, but they were talking about how easy it is to just prick your finger at the same time showing somebody pricking their finger and blood pouring out of the tip. And I thought to myself, well, that doesn't look very easy.
No, it's certainly not. It's certainly not. And if anyone knows someone with type 1 or even type 2, it's painful. And some people have to do it 15, 20 times a day
Oh,
if they're
wow.
not under control. So it is not an easy thing to do.
Sure.
And also what Dexcom has done for patients, customers, is that we're approved for pediatric use. So you can imagine having a 2, 3-year-old having to prick their finger every hour or so. That's not a good situation, and that's why our device has kind of been a disruptor in that sector.
Yeah, and I remember seeing an actual commercial for Dexcom as well at some point in the last couple of years, and how easy it was to have that. My dad, suffers from this as well, and he's always constantly checking. So it's really something that maybe he should look into. I think I've mentioned it to him, but he's a little averse to new technology and things like that. But maybe someday I'll convince him. But
Yeah.
Yeah, thank you so much for what your company does. It's very important. So, when you're an engineering systems manager, and I did this job for a couple of years as well, and I got out as soon as I could. But it's where I lost all my hair. That's what I joke around about, because I was getting calls from India in the middle of the night. Oh, our server's not replicating, and China's down, and now Italy's upset because the performance is bad, and it's like it was one of those kind of situations where we had a team of CAD administrators, because it was a fairly large organization. But what is your day-to-day like at being a systems engineering manager at Dexcom? You can talk about how it maybe obviously you're running parallel systems, right? So maybe you can share a little bit more about what that's like.
Yeah, so I mean, let you describe it perfectly. So a big part of the job is just making sure things are running, from servers to our users having installations. I mean, there's a lot of instances of users getting new computers, or they got the computer reimage, or we're onboarding new users. So installations, maintenance, updates, it's a big part of the job, and is the non-fun part of the job. So yeah, that's still a thing, and then we're trying to get away from it.
And how are companies like yourselves trying to get away from the hardcore management? I might know a few solutions, but SaaS is typically one of them, right? Cloud first type initiatives and things, right?
Yeah, so in this regard, I mean, explicitly, it's Onshape and has been Onshape, and that's kind of why I kind of been very curious about when I first heard about uh, Belmont Technologies a few years back. I was curious about the product. At the same time, had been attending regularly the SolidWorks conference every year, and kind of seeing how the offering was developing. And then as it kind of became more mature, and at the same time we got exposed to Onshape, you started to do the analysis of like, what are the technical differences here between these two systems. And then it kind of became pretty apparent that if we were to go to that kind of cloud enabled scenario, Onshape was far superior in terms of what it offered in terms of value for the effort of migrating CAD systems in this case. So yeah, the kind of elimination of all that overhead of the CAD admin, the non-fun part of the job, and also the non what I like to call is the non-value added part of the job. Because as an admin, you're just making sure things run. So that doesn't really add value to the organization. So what we're right now are transitioning into more of a solutions provider sort of. Where can we, as an admin, if you're not doing half of your job, then what are you going to be doing? So the what we've been looking into is like expanding our role into like automating and documentation, best practices. So just kind of process improvement. So all those kind of processes and workflows that an engineering team typically is interacting with, they all can be improved. They all can be optimized. It can be more efficient.
Yeah.
So in the position of my team, the CAD engineering or the CAD manager team, we see all those interactions, we see all that collaboration that is needed and it's happening. Whereas an engineering manager or an engineer themselves are not going to see all those kind of notes that his kind of daily work is hitting with other departments and other business systems like PLM, ERP, MRP. So that's kind of what we're transitioning our team to be more of a internal solutions provider, instead of just support and maintenance. So that's kind of being the exciting part of having a system like Onshape, a platform or a solution, is that it's going to enable not just us as a team, but the company to be more efficient and more agile. And that's kind of the ultimate goal.
Yeah. With having, removing that portion of your day and focusing on the success of your engineering team. That sounds a lot more exciting actually now, being a CAD systems kind of manager to do those kinds of things, right? You're focusing more on things that can help the company instead of putting out fires and in those types of scenarios. So it's really an exciting field. There's other possibilities like you mentioned with programming and software. You mentioned Dexcom, is heavily obviously into software as well. And you mentioned the word agile. Agile processes and techniques were kind of born from that software world. But
Yeah.
how would you compare, doing things in, like, let me put the question this way. When doing design work nowadays in Onshape, we've borrowed some concepts from that software engineering world, from GitHub and those types of management techniques. Have you been exploring those things? And by being a software sort of company as well, has that been helpful in learning about Onshape?
Yeah, for sure. So that's kind of like we have that internally, where a big part of our R&D team is the software end of it and firmware for our hardware. But we're definitely identifying those opportunities in the product development and on the mechanical and hardware side of things, where having something like Onshape, and it's not just like alleviating the pains of a CAD admin or a CAD engineering, like all of these pains with like file management, and like not being able to access a file simply just because you're not on the right device, or because you want to share with a program manager, a project manager, or with quality or other departments. uh, with SolidWorks or a traditional CAD system, they have to have that installed. They have to have the right machine. They have to have the right environment. Whereas with Onshape, it's simply you just grab the little hyperlink button, you copy it, you paste it over a Teams message or any other communication platform, and then they're in. You're collaborating. So that has definitely been one of the things that we're focusing in, is how can this accelerate like the built-in commenting and interaction, the kind of endless uh, moments in time of the design process, where you can revisit literally any moment in time of the specific design and collaborate and discuss it. That enables things that have been really not even discussed because they were not possible
Not
in the
possible,
past.
right?
Yeah.
Right. Yeah, I put
And
a
you
post out
mentioned,
there the other
yep.
day, and it got so much attention. I was like, it was a simple thing. I was like, oh, wouldn't it be cool if you could find out which engineer edited Hole 3?
Yeah.
And I don't
Yeah,
think there's any other CAD system that could tell
that
you that.
was that was interesting, because after you posted that, I got curious about like what else, or how else could we use this. So I just started playing with a couple of documents and went through the history, and I realized you can, and I mean, I've been using Onshape, but I don't design on a daily basis. Uh, and I was like mind blowing. You could literally go through a history of a months or years worth of design, and then go back in time and create versions back in time.
Mm-hmm.
And that was just like, whoa, this is like impossible, like literally impossible with a file-based system. And that's something that I'm excited to share with the design team. And like, look, if you have a history, you were working on this last week, but now you want to go back, you can go back and create a version, and not just on the current like workspace, but also in, like between previous versions, like between version 1 and 2, you wanted to capture one, you can go back and create version 1.1, and like, whoa, that's
branch
just
from there, try something
yeah,
new, see what happens. Yeah.
yeah. So that
Yep.
was exciting
You
stuff.
mentioned You mentioned earlier, Adrian, about having to make sure that you have the right setup. You have to have the right graphics card, and what once you get to that point, you get excited, happy. What ends is a year or two later, you have to have something, or you have to have something up, and with with native Onshape, that's in any browser.
Right.
Yeah.
Go ahead, Adrian. I'm sorry.
No, I was just gonna say, yeah, for sure. That's been one of the things, especially in the last couple of years, with a lot of new folks and different industries being part of our product development. A lot of the engineers and managers are into getting Mac computers, and they're part of the mechanical design team. But because they're not necessarily 100% like SolidWorks or designer type of users, I mean, they get a Mac, and then all of a sudden they need access to PDM, and they come to us and like, "Hey, can you get PDM set up in my Mac?" And I'm like, "Yeah, yes, but no."
You're not gonna like it.
You're not gonna like it.
Yeah. So that
We on the show we had Terry Wohlers talking about it. How does Dexcom manufacturing in the manufacturing process?
I think you're just cutting out just there a little bit there, Richard.
Yeah.
Oh, what's I?
Yeah. So I think what you were asking about is additive manufacturing experience at Dexcom. Is that correct?
Yes.
All right, great. Yeah.
Yeah, so we part of our design, or especially early concept design, definitely involves 3D printing, prototyping, and like just getting concept, either like on the user experience, industrial design part of it, or on the mechanism side of it. So I know we do have a full suite of the different technologies, SLA, FDM, and I don't even know. Like saying to you guys, I haven't been in the office in 2 years, so I haven't seen our lab and what we have. I do know we have acquired a couple more machines. Was really excited about yesterday's release on the mix modeling because we do have 3D scanner data that we could leverage. So that's definitely going to be enabler of our design process.
Great. Yeah. So your company has decided to bring in technology. You use it enough that it pays for itself and it's valuable. So that's another way of looking at this. And you have service bureaus, you have your traditional kind of side kind of 3D printers that you might have in your home office, and then you have like the professional kind of production machines that a company would put out there on the manufacturing floor and in a lab somewhere. Yeah. We also have a lab at our office at PTC, about 15 different machines as well that we do little proofs of concepts on and things like that. It's so valuable just being able to walk right up and have something.
Absolutely.
Yeah. Maybe I'll ask a similar question like I asked to Terry earlier. I love origin stories.
Yeah.
So, maybe in this particular case, what was the first time you saw Onshape? What did you think? What went through your head?
I don't remember the exact first time I got into it, but the first thing I did was grab the hyperlink and send it to my friends, like my colleagues, fellow engineers or designers.
Yeah.
And just because it's like what's going on? It's like I can pull up a model and then just get a URL and send it to you, and then you're in the model.
Yeah.
And this was at the time where I was working at the company. We were doing very, very large assemblies, and just sharing your design, native design, was just something unheard of.
Mm-hmm.
We've tried like a ton of things so we can get our job site engineers and our installers like data, even 2D data was in native format was difficult. Um, so the first thing I did, it was just grab the URL. It's like, hey, look at this. We can design and you can fully fledged CAD. That was what I remember was one of the first things I did for sure.
Yeah. Yeah. It's similar to me. I kind of went off the deep end a little bit when I first saw it. I quit my job the moment I saw it. But I was the president of the SolidWorks Boston North user group, and I was so compelled to talk about Onshape. I even brought it up at the SolidWorks user group. I was like, "Hey, look at this amazing thing!" I was just a raving lunatic at that point. But it really it gets at you. Like it's I had that same feeling I got the moment I first saw SolidWorks too. Like when I first saw SolidWorks back in 1995, I was like, and started playing with it and using it. It's all I could tell people about and share, and being able to share a link to something of a large assembly. Like if people on the podcast don't recognize that that's a really difficult thing, it is. Like being able to package up and zip up all those files. They have to have some kind of advanced system to open it. You have to get it to them somehow.
No, that's definitely. I mean, it goes by like quickly. Like after the first couple of times you use it, you don't think of it, but just because you don't have to do it. If you had to do like the file-based way of sharing designs on a regular basis, and then I mean that's what happened like to me, like being on that kind of piloting exploratory phase with Onshape, and then on my day job I would have to go back to the file-based system, and I was just kind of like bumping my head. It's like things would be so much easier for everyone. Not just want to make this point because I've been talking about like the CAD admin role, but not just for the CAD admin, but like as a designer, I was thinking back at my designer days, at my how this would change everything. So I kind of that's why I started to push, and of course it took time. I mean, we didn't pitch Onshape to our leadership right away. The first time we saw it, we kind of explored it, let it build into the tool that we felt was ready for our needs, and it is now. So that's where we are.
Great. Well, Adrian, thank you so much for joining us. Richard, do you have any final questions?
I don't have final questions, but like you, I very appreciate Adrian coming on the show. We will get together. We'll host that Spanish language Onshape user group meeting. We'll get that going as soon as we can, and hopefully we'll have you back on the show at some point too.
Awesome. Thank you guys. Thank you for having me. Yeah, I'll have to pick up on my technical Spanish because all my professional life has been in English. So whenever I hear engineering terms in Spanish, I'm as lost as probably you guys.
I've heard that too.
So yeah, but no, that it should be exciting. It's one of the things also about Onshape that we can just jump on a user group meeting, or we could collaborate. We need. We can, like I was proposing the other day on the embassy, is like we could build an environment and collaborate for different purposes. So that's just not possible with anything else right now.
Coming soon for the ambassadors. We'll have that set up.
Awesome.
Cool. All right. Well, once again, thank you again, Adrian. Have a great day.
Thank you.
Don't be a stranger.
Yep.
Likewise.
It's always good to hear from Adrian, such a refreshing person, I think, and has a lot of good stories as well. So
wow, a couple of really top-notch interviews today.
Yeah, definitely.
We got lucky with that one. So up next, we've got a great model of the week, haven't we?
Oh yeah.
Right. Yeah, let's not forget that.
Yeah, model of the week. Let's see. Let me
and this is a public model available in Onshape. We'll put that link there in the show notes for you.
But this model of the week, it's by the time you hear this, it'll at least be May 5th. But we, as you know, we record these things a week or so in advance. So this kind of has a little bit of a Star Wars story for May the 4th, but it's also a really cool historic reconstruction of a mechanical calculator that, we talked about a few years ago, but it's just one of the most cool historic designs that I've seen in Onshape that somebody's built and has been maintaining over the year. Marcus Wu is the the Onshape user who has built this. Here he is. And you can see a 3D printed out version of that hand crank calculator there with, it looks like a few Star Wars figures here. Here we are. Bounty Hunter, Princess Leia, Hoth and Solo. This
may
model,
the fourth be with all of you.
May the fourth be with you. Here's the actual model that you can see in the public forums. It's been liked quite a bit and used, and
copied quite a bit.
Have actually used it in their assemblies. That's what that means up here at the top. So pretty intense design. Let's actually do a quick section view just so we can see this. This highlights some of our new section view capabilities as well, with excluding certain parts. Maybe you want to you don't want to cut through the round parts perhaps, right? So you can see things like this and slice it open in a nice pleasant way. But
this model just makes the mechanical designer in me just giddy.
Yeah. I mean, it's a work of art and precision device, right?
Yep.
And the everything's been named very nicely. There
I think there's even some animation in there, isn't there?
Is there an animation? Let's see if I can find which one it would be. Well, I mean, I could definitely just grab it like this.
Oh, there you
right?
go. Yeah.
So you see what I did there, by the way? That's a little power tip, right? If I pick on a part, you see how it puts the triad just wherever I picked?
Yep.
But you can drag and drop that, and it will find an automatic mate connector.
I learned that in one of our user group meetings several weeks ago and have used it extensively since, especially with imported geometry. That was one of it seems so simple now that I know how to do it. But one of the things that I was struggling with imported parts was how to orient it in the direction that I wanted it to be in.
Yeah.
And I learned that nifty little trick, and it's been easy ever since. So.
Yeah, it's much use to use that particular method. And now I can start dragging this and make sure
there you go.
I got the animation going there. So of course you could find whatever mate it was. A good little tip is to show that mate, and that way it's available. But really great organization, and it's been worked on as recently as a few days ago.
Yeah.
So he's not done with it.
Yeah, I love the organization. That's to me, that's really, really important. And I'm in awe of people that do that without even thinking. Sometimes you get busy and you start creating some features, or you say, well, I'll come back and I'll name them later, and you never do. And so I appreciate something like that.
Yeah. So that is the model of the week,
and a great one at that.
Yes. All right. Let's remove that.
Well, we've had ourselves a pretty good show today, huh?
I think so. Yeah, it ends up working out. We, the people we have coming on the show are just great guests, and really want to thank them for taking their time out and sharing their stories. I think it's really important to hear, if you're investigating changing technologies, to hear these stories to understand what you're up against, right? So.
Yep, absolutely.
What do we have next time?
I'm also excited. I'm also excited about the next episode. In the next episode, we're gonna call it Speed Modeling. And we've got a great guest coming in, Toby Too Tall Schnars, longtime CAD guy, and he's the host of Model Monday Live and the monthly speed modeling competition on YouTube.
World famous for the guitar song,
the fully defined song. That's a ukulele, by the way. I've seen Toby perform that in person. I failed to get his autograph at the time, but maybe we can. Maybe if I send him a ukulele, he'll autograph it and send it back to me. That'd be a really cool thing to have. We're also hoping to talk young Alanus into joining us on the next episode. We'll see. He's a busy kid these days. He's got a lot of stuff going on in college, but we hope we can get a few minutes of his time because he has participated in Toby's speed modeling challenges. Yeah. And it'd be interesting to hear his take. So looking forward to that. For those of you that are watching or listening today, please hit the subscribe button. You'll never miss an episode. And if you like what you saw, hit the like button for us. We'd sure appreciate it. So it's been a great show. It's always great to be here with you. I can't imagine having any more than doing this. So
yeah, it's a great game. All right, we'll see you all next time.
All right, take care.